Hi, I'm Eric Swenson from Nichia. I'm very excited to talk to you today about a subject I've become very passionate on lately within the last year or so, and that's on the subject of lifetime, specifically lumen maintenance of LEDs and LED products. I've been very fortunate in my time with Nichia over 11 years now to meet a lot of intelligent people, a lot of great people. I've seen a lot of amazing, innovative designs. I've really seen the adoption of LED take over, and it's been a great technology. It's been a great run, but I'm really disappointed over the last year. We've seen a snowballing effect with regards to lifetime with a lot of exaggerated claims, and I feel this needs to be addressed by the industry at all levels, from an LED manufacturer to a fixture manufacturer to a lighting designer and specifier. And I think a lot of it goes back to education, really understanding how lumen maintenance numbers are developed and measured, how they're extrapolated and estimations are made. What is LM80? What is TM21? How can those numbers, how can they be used? How should they be used? And I want to address that and educate the market on these subjects. So starting off, I kind of wanted to describe what is LM80. Everybody's familiar with this. Some know the details, some don't. Some know of it as the way to define quality. Really what LM80 is it's a test that LED manufacturers must follow. It describes the how. How do we perform lumen maintenance tests? How do we test an LED to measure its lumen maintenance over time, its color shift over time, its voltage shift over time? This was a great first step for the industry. Prior to LM80, every LED manufacturer stated their lifetimes, stated their presumption of lifetime in different ways. They all performed their own internal tests, came up with their own presumption of life. Nothing was standard. LM80 was the first step, a great first step, because it standardized the industry on how to define long lifetime for an LED. A couple points with LM80 that need to be mentioned. Number one, if you want to apply for DLC or Energy Star certifications, this testing must be done at an accredited lab. Second, LM80 doesn't define how to presume lifetime, how to extrapolate. And then lastly, LM80 doesn't give you a pass-fail criteria. Now, when we're doing that testing, or an LED manufacturer is doing that testing, they are required to test a minimum of 6,000 hours of testing. Additionally, TM21, which I'll talk about next, defines that those measurements must be taken every 1,000 hours. So what is TM21? TM21 is taking that LM80 data and defining how to come up with the long lifetime expectation, how to do the calculation. It defines the calculations to get your L70, to get your L80, to get your L90. It's defining the calculations, which I'll repeat over and over again. It is exactly that, a calculation. Again, there's no necessarily pass-fail criteria. It's purely defining the calculation. Again, this was a great second step for the industry because it's taking the LM80 data, telling you how to come up with a long lifetime point. The key, and where we start to deviate from where the original intentions were, is when it comes to the calculation and how you use that value. TM21 clearly defines that the calculated value is purely that, it's a calculation. When it comes to reporting the lifetime, you should be limited to 6x the amount of hours that you actually test. So if you test an LED out to 6,000 hours, the most you should be reporting from a TM21 value is 36,000 hours. If you test out to 10,000 hours, you can claim out to 60,000 hours. What is happening, and what we've seen a lot of, is that calculated value, which might be forever. It might be 1,000,000 hours. I've seen it on our products. I've seen it on other products. It's not realistic. It's purely a calculation. Where we're starting to go bad as an industry is that calculated value is being used in the market. It's being used as a marketing tool. It's being used to help sell products, when we all know that's not realistic. It's purely a calculation. We must limit that reported value in marketing, in submissions for certifications, to only 6x the amount of hours. And that was set by the working groups and the committees that came up with these standards, because that's the confidence level that they have, is out to 6x the amount of hours. And again, TM21 was developed to basically establish a baseline. It was never meant to be a calculation to be used to compare LED to LED or fixture to fixture at very long lifetimes. It was meant to develop a baseline. Energy Star created 50,000 hours L70. DLC later came out with, again, 50,000 hours L70 for DLC standard. L90, 36,000 hours for DLC premium. These were set to be baselines. Anything beyond that point, it was not meant to be comparisons, because at that point there's so many anomalies, which I'll get into next, that really don't allow you to compare LED to LED beyond that point. So next I kind of wanted to talk about some of the anomalies and areas where TM21 can be misleading. And before I get into that in depth, I wanted to talk to you about what are the breakdown mechanisms of an LED? How does an LED experience lumen depreciation? And I want to focus on two different types of LEDs. The first is a very popular, used in mid-power packages. It's a thermoplastic, whether that's a thermoset material, thermoplastic material, or purely just a plastic package. The breakdown mechanisms there are going to be unique. The first breakdown mechanism where it's going to depreciate over time is with the housing. The optical energy from the chip is going to bombard the plastic packaging, and that's going to degrade quickly. That's going to degrade in the first 100 to 5,000 hours for the most part, depending on the temperature. And what's happening is that package is basically browning to exaggerate. It's becoming less reflective, less light is coming out. That's going to be the first degradation point. The second, which any LED is going to experience, is the die. There's going to be slow degradation over time when it comes to the die. With a ceramic-based package, you don't have that degradation of the housing material, you have the degradation of the die itself. So again, that's going to be a slow degradation over time. So now that you understand the breakdown mechanisms, I wanted to give some examples of how the TM21 calculations can vary and be misleading and not represent reality. Some of the first experiences we've seen with LEDs is pertaining to the calculated value. I'm sure you've seen reports, whether it's Nichia or any LED manufacturer, where that L70 comes out to over 1 million hours. 1 million hours of lifetime lumen maintenance to hit 70%. That's over 110 years. Come on, that's not realistic. We're not going to have any LED that lasts that long. That's an L90 of 35 years. That's not realistic. The second anomaly I wanted to talk about has to do with measurement variance when it comes to an LED. We're only testing 25 samples. We're testing them every 1,000 hours, out to maybe 10,000 hours of testing, so it's a very small sample set. If there's any bounce within that LED, whether it's measurement tolerance or just small variances, that can have a big effect on the overall TM21 calculation. I've seen LMAD reports in the industry where because of that bounce, when you do the reported value, it ends up being a flat line. The LED lasts forever. That's amazing, right? It's not realistic. If you look at the calculated value, it actually goes up over time. So the LED is getting brighter over time. This is another example of where TM21 has some small flaws. Again, a great step, but there are unique flaws to it that don't represent reality. Third example to talk about is related to temperature. We all understand the hotter the temperature, usually the lower the lifetime. The lumen maintenance is much shorter, and that's accurate. Heat is bad for an LED. However, sometimes you'll see examples within the LM80 report where a higher temperature, let's say a TS of 105, has a longer TM21 value than 55. We know that's not true. It's not realistic. An LED that is at 55 degrees C is going to last longer. It's going to have a longer lumen maintenance than one at 105. But again, the TM21 calculations and the way the LED degrades over time, when and where that happens during that 10,000 hours, is critical to the overall TM21 projection. So continuing on the subject of temperature, what you're looking at here is an example of how temperatures can vary within an LED, and it has a major effect on the overall TM21 experience and calculated values. So what you're looking at here are two different LEDs under test. First is a 55 degrees C, the second is 105 degrees C. When you look at the first 100 hours, it goes just as expected. The higher temperature LED is starting to experience the first breakdown, which, as I spoke to before, is the housing material. That's starting to break down, become less reflective. The lumen maintenance is starting to fall off. That happens right around 200 hours. At 1,000 hours, that wraps up the depreciation of the housing material, and you start to basically just have the slow degradation of the chip over time. It's a very flat and slow degradation. When you look at the 55 degrees C LED, it again goes just as we expect. It remains flat early on. It doesn't start to experience the housing breakdown mechanism until around the 1,000 hour mark. And that is a degradation that really doesn't start to flatten out really until about the 9,000 hour mark. That's where you start to see it flatten out and have the slow degradation of the chip. So this is critical and ties very closely to the TM21 calculations. One thing I didn't mention with TM21 is you are required to use the last 5,000 hours of your testing and use that data for your TM21 calculation. So in this case, you're looking at this LED was tested out to 10,000 hours. So we are required to use the test data from 5,000 hours to 10,000 hours and do the calculations based on that to come up with our estimated L70 value. The higher temperature, as I mentioned, is a much flatter line. It's experiencing its slow degradation, a very flat slope. So its extrapolations are going to look great because that window, that 5,000 hour window, is very flat. However, when you look at that 55 degrees C LED, that's still in the midst of its housing breakdown mechanism. That 5,000 hour window is capturing that steep slope, that steep fall off. So when you do those calculations, you're capturing a very steep slope and your lumen maintenance projections are going to be much worse. Again, this goes against theory because when you look at the actual long lifetime expectations, the green line, you'll see that that 55 degrees C LED is expected to last much longer than what the TM21 calculations show. We see this a lot. This ties to do with just the temperature, any bounce with the LEDs. When and where that slope happens and that steep degradation occurs has a major effect on the overall TM21 calculation. One piece of LM80 that gets ignored regularly is the color shift portion. All the attention gets put on lumen maintenance because it's a piece everybody's aware of and understands. It's very easy to predict over time. There's calculations, albeit they do have their flaws. Color shift, while it is an active piece of LM80, it's not a linear shift over time. It doesn't shift in the same direction linearly over time, so it's very difficult to predict. The working groups are trying to come up with a standard for it, but kind of like TM21, if and when they do, it's going to have its flaws as well because it's not linear. It's going to be very difficult to predict over time. So now that we've talked about LM80, TM21, some of the innuendos that go with it, I want to share some stories and things we've seen in the industry of how these are getting misused, how these calculation values are getting misused, reported values are getting misused, and it relates to the whole system. And not only fixture manufacturers, but lighting designers and specifiers really understanding the guts behind it. DOE published a report recently in 2017 talking about recommended new research topics, and there was a section focused on reliability, and I'm very glad because they brought up a lot of key points. The LED is just one small component in the whole system. You have drivers, you have circuit boards, you have optics, you have the LED, you have many components in the whole system. The LED is just one piece of the puzzle. There are a lot of other components in the system that have rated lifetimes far lower than the LED. Anything using capacitors, most capacitors aren't rated beyond 40,000 hours. So to utilize the LED's lifetime and state a fixture's lifetime or base a requirement off of an LED's lifetime is just doing a disservice to the industry because it's not reality. The LED is never the weakest link in the whole system. And this brings to the topic that I've really become passionate about and I want to educate more people about and talk about more because I think a lot of people in the industry understand this and get it, but unfortunately there's such a big snowballing effect that we hear a lot of negative things that go against honesty and reality. I've heard time and time again when talking with engineers and talking with fixture manufacturers, Eric, I get it, LEDs don't last forever. I get it, 1,000,000 hours L70 isn't realistic. But you know what? My competitor claimed that, so I have to do it. I have to market it. Come on, that's not realistic. We're all in this for the long haul. Why do a disservice to the industry and technology just because my neighbor is doing it? Another point that I hear regularly is LM80, TM21, it's just to check the box. Eric, again, I know it's not real. I just have to check the box so I can submit my application, submit my product for a design win. Again, we're much better than this. We're much smarter than this. Let's do things the right way. LED technology is amazing. It lasts a long time. We don't need to, again, do a disservice by exaggerating lifetime claim. So again, thank you for taking the time to listen to my talk. Again, it's a subject I've become passionate about. Hopefully through more discussions, more education, more honesty, we can really start to route the ship in the right direction again and continue on a technology that doesn't need exaggerations. Again, thank you very much and have a great day.